and welcome back to Cyber Heroes. As we are going to continue network models here. TCP IP model. In previous video we discussed what is the use of these OSI model and TCP IP model, which layer, what is their responsibility of every layer we discussed yesterday. Today we will see a real example and the difference between main two protocols TCP and UDP. So let's start first an overview of this network modelings. First TCP IP model and OSI model. OSI model is a theoretical and TCP IP is a practical model. In TCP IP model there are 4 layers: application layer, transport layer, network layer and network access layer. In OSI model there are 7 layers: application, presentation, session layer. These 3 are combined to make a single layer that's called application layer in TCP IP model. What are the protocols used? For an application layer, FTP, HTTP, Telnet. Presentation layer, JPEG, MPEG, NFS, session layer, SQL, PAP, TCP, UDP. For transport layer, TCP and UDP. Then for networking layer, IPv4, IPv6. Data link layer, ARP, CDP, STP. Ethernet, Wi-Fi for network access layer. It's combined of 2 layers, data link layer and physical layer. So let's start. I hope this is clear. Now going here. Then first, and not what is actually networking models, as we have defined it. How data is transmitted and received over a network. Simple definition: data transmitted and received over network. Don't worry about notes. I will provide a link in description for a Telegram channel where I will upload the notes. Don't touch about that. Then what is the full form of OSI? It stands for Open System Interconnection. It was developed by ISO, International Organization for Standard Conceptual Model, for understanding. Then we have seen that what is the purpose of these layers. Let's go for difference portion. What is the difference between them? So, how many first different about layers? For an OSI model there are 7, for an TCP model there are 4 layers. Then approach, it's a theoretical and this is a practical. Then if we'll say a protocol dependency, short form protocol dependency, here it protocol independent, and this one is protocol specific focuses. The TCP on TCP IP. Then an example use, if we'll see where they are used. This for teaching and conceptual method. Short form teaching and conceptual method. Here it is practical portion. This is difference between these two models. I hope it is clear. Now going to the next one, TCP and UDP. So both in transport layer protocols, layer in OSI and layer 2 in TCP model. First I would say the connection. Let's differentiate using some features. First one, connection. As TCP is connection oriented and this one is non-connection oriented. This one is not connection oriented. No connection handshake there. Yeah, UDP. This one is UTP and this one is TCP. Not connection oriented. Reliability, if you want to see reliability. The TCP is reliable retransmission and acknowledgement. They are reliable. Let me use short form reliable. This one is unreliable. Then moving to the next difference, ordering. Ensures correct order. TCP ensures correct order. Ensures correct order. No order guarantee for UDP. No order guarantee. Then one other difference we can say speed. TCP is slower than UDP. UDP is fast. TCP is slower than UDP. Then flow control. We can differentiate characteristics of flow control. On TCP there we have flow control, but UDP we don't have flow control. Use case example, web, website, email, file transfer, so on so on. For UDP there is an example, streaming, gaming, and DNS. Then we will go for main thing, real example. Let's say a real example. Let me delete this. We'll go for a real example. Just like when we'll type on Google www.google.com, what happens to this site when you visit google.com? How it works through OSI TCP IP model. Let's understand. First, application layer. What happens there for an application layer? This is the wire user application and high level protocols work. Example, HTTP, HTTPS, so on, DNS. Okay. It's just when we type www.google.com in our browser, so DNS here works. How DNS? What does DNS do actually? It translated this query, what we wrote, google.com, into the IP address. What can be IP address of Google? For example, 1.7 whatever, something. So DNS will convert this query to google.com into the IP address. First thing it will happen. Then moving through the transport layer. What will happen here on the application layer? What actually happens? DNS takes place there, converts the google.com into the IP address, transport layer. Then browser sends HTTP request like get index.html using TCP segments. Send HTTP request like etc. How the connection here will be generated. Let's see. HTTP uses TCP, right? HTTP will use TCP to create a connection with Google server using three-way handshake. If you know three-way handshake, good. If you don't know, no worries. We'll see here. First sync packet will be. Client said, I want to connect. Then after that sync, ask. Server says, okay, I am ready. If you are not getting this, no worries. We will see in diagram, but that it will be clear. Then ask. Client said, let's start communication. Three-way handshake, TCP. Here is the image. Sync packet will be sent first through client to the server. Server receives the sync element sequence will empty. Like sync packet will go through. Then it will send back sync policy acknowledgement to the client. Here is I want a connection. Server says, yeah, okay, I am ready. Then it will receive. So let's start the communication. This is called three-way handshake. First, second, third. I will explain it in simple words. If you want detailed video on this three-way handshake, how to establish it, etc. Then just inform me in comment sections. I will make a separate video for this three-way handshake. This is an overview. I hope it's clear. Let's move towards next. So the browser sends IP request like getting this to this. Then it moves to the internet layer. Internet layer. It is responsible for logical addressing and routing. Some protocols you are using IP like IPv4, IPv6, ICMP, and ARP. The TCP segment is encapsulated into an IP packet. TCP segment is encapsulated within an IP packet, which you got by DNS, right? Then the source IP, which contains some source IP and destination IP. What will be source IP? Your computer IP, your mobile IP, from where you are typing google.com. And destination IP, what will this? Google server IP. Google server IP. So routers along the way use the IP transmission to forward packets towards Google data center. Moves packets from source to destination using IP addresses. Then network access. Network access layer. Network access layer. What can be your protocols here? Ethernet, Wi-Fi here, so on, PPP. Your computer sends IP packet over Wi-Fi or Ethernet. The packet is converted into frames with MAC addressing your device and your router. This was the packet. It is converted into frames, MAC address. That is your device and your router. Then the router transmits the signals over cables or wireless radio to the next network devices. So this is how the google.com works. So if I will give a summary, so what does the application layer do? Browser requests page and remove domain name. This is the responsibility of application layer. Then transport layer creates reliable connection with Google server. Then internet. It routes data across network using IP addresses. The network access sends bitwise physically over the network. So this was all about the working of this TCP IP model with the real world example. I hope you like this video and make sure you hit the subscribe button. Take care. See you in the next video. Bye bye.